NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this lesson, we will factor a quadratic trinomial when it has a double root. Our goal is to show that if ax squared plus bx plus c equals 0 has a repeated root x sub 1, then ax squared plus bx plus c equals a times x minus x sub 1 quantity squared. Theorem: if the equation ax squared plus bx plus c equals 0 has a double root x sub 1, then the trinomial factors as a times x minus x sub 1 squared. First, a picture. When a quadratic has a double root, its graph touches the x-axis at one point and turns around. That unique contact point is the repeated root. Let's sketch a parabola that just kisses the x-axis at x equals 1.5. Now the algebra. For a double root, the discriminant delta equals 0. That is b squared minus 4ac equals 0. For a repeated root, the location is x sub 1 equals negative b over 2a. From b squared minus 4ac equals 0, we rearrange to c equals b squared over 4a. Next, factor out the leading coefficient, a. Then substitute c by b squared over 4a. The part in parentheses becomes a perfect square. Recognize a perfect square. A squared plus 2ab plus b squared equals a plus b quantity squared, where a is x and b is b over 2a. So this equals a times x plus b over 2a quantity squared. Since x sub 1 equals negative b over 2a, this is also a times x minus x sub 1 quantity squared. This matches our picture. A times x minus x sub 1 squared is a parabola with its vertex at x sub 1 on the x-axis, touching but not crossing when it is positive. That single touch is the repeated root. Example: factor 4x squared minus 12x plus 9. First, the discriminant. b squared minus 4ac equals 144 minus 144 equals 0. So it has a double root. The root location is x sub 1 equals negative b over 2a, which is 12 over 8, equals 3 over 2. Therefore, the trinomial factors as 4 times x minus 3 has quantity squared. Recap: a double root means delta equals 0. Then c equals b squared over 4a, and the trinomial becomes a perfect square, a times x minus x sub 1 squared. Keep this pattern in mind whenever the discriminant is 0. In this video, we will factor a quadratic trinomial using the discriminant method with clear step-by-step visuals. First, our example. Factor b equals 9x squared minus 6x plus 1. Step 1. Identify the coefficients. Here at equals 9, b equals negative 6, and c equals 1. Step 2. Compute the discriminant delta. Delta equals b squared minus 4ac. Substituting. Delta equals parentheses negative 6 close parentheses squared minus 4 times 9 times 1. That simplifies to 36 minus 36, which equals 0. Step 3. Find the root using the quadratic formula. X equals negative b plus or minus the square root of delta, all over 2a. With delta equals 0, x equals negative parentheses negative 6 close parentheses plus or minus 0 over 18. That gives x equals 6 over 18 or 1/3. Because delta equals 0, both x1 and x2 equal 1/3. Step 4. Factor using the repeated root form. When there is one repeated root x sub 1, we can write ax squared plus bx plus c equals a times x minus x sub 1 quantity squared. Substituting it equals 9, and x sub 1 equals 1/3, we get 9 times x minus 1/3 squared. Bringing the 3 inside the square gives 3x minus 1 squared. Therefore, b equals parentheses 3x minus 1 close parentheses squared. As a quick verification, expanding 3x minus 1 quantity squared gives 9x squared minus 6x plus 1, which matches the original trinomial. In this example, we will determine the quadratic function of a parabola directly from its graph. The graph is tangent to the x-axis at x equals 2, and it passes through the point 0, negative 2. We will follow 4 clear steps to find the exact equation. Let's draw an xy coordinate system and sketch the parabola. We will highlight the tangency at x equals 2 and also the y-intercept at 0, negative 2. Step 1. Identify the double root from the graph. when a parabola is tangent to the x-axis at a point. That x value is a repeated root. Here the touching point is x equals 2, so x equals 2 is a double root. Step 2. Write the function using the squared factor that encodes the double root. For a double root at x equals 2, the function can be written as a times x minus 2 squared. Step 3. Use the known point 0, -2 to solve for a. Substituting x equals 0 and f of x equals -2 into a times x minus 2 squared gives -2 equals a times -2 squared. That simplifies to -2 equals 4a, so a equals -1/2. Step 4. Write the final function by substituting a equals -1/2 into the factor form. So the function is f of x equals -1/2 times x minus 2 squared. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.